It's Veterans Day. And being a veteran myself, along with a number of you in the room, our panelists and those that are serving, I think it's really appropriate that tonight we start this event with our national anthem. Will you please stand? Okay, I want to thank these companies. We have 8 of them that you saw out in the lobby today with their technology and the products. Terrific startups here in San Diego. We also had Qualcomm there with their booth, their table showing off the new Snapdragon Flight reference design. In addition, we had the Boy Scouts here. Now, what do we have the Boy Scouts here? Did you know that many Eagle Scouts go into engineering? Did you know that many of the Eagle Scouts become our greatest leaders, greatest not only political leaders, but business leaders? Terrific organization. So we want to welcome the Eagle Scouts here tonight as well. Next slide. As you probably know, Evo Nexus is a nonprofit. Much of what we do is pro bono for the community. We take no fees. Tonight, if you're here and you paid nothing to attend, chances are your company is on this slide. If you arrived here tonight and you had to pay us something, make sure your company is on this slide and you go free next time. So see me afterwards. I want to thank our strategic funding partners, and what this means is these companies are partners of Evo Nexus that review all the companies in our incubator. We have 56 of them now. And if those companies are doing something that falls in their areas of interest, they'll provide seed funding for the startups at Evo Nexus. That's a huge advantage. Huge advantage. And these are great companies here in San Diego. One of them is actually based in the Silicon Valley. So, as I told the Cisco executives a couple of years ago, there really is intelligent life south of San Jose. Okay, next slide. One of the most visionary companies in innovation actually is not a technology company. It's a real estate company called the Irvine Company. The Irvine Company provides Evo Nexus over 50,000 square feet of free incubation space, tri-lab space. If Evo Nexus, a high-tech incubator, was to have a transformational impact, it needed a real estate partner that shares our vision and long-term commitment to fostering growth of tomorrow's San Diego tech company. That's the Irvine Company. Also like to recognize Qualcomm. Did everyone enjoy the hors d'oeuvres? The wine, great. Thank you, Qualcomm. In addition to providing this terrific venue where we hold almost all of our headliner events. So it's just a terrific venue for us. It's right in the center of tech. Couldn't be better. Should also point out that tonight's event is all about robotics and drones, and Qualcomm really has become a leader in that area. They've been developing technology that will be in future drones and robotics. They've been doing that for years. In fact, recently they developed a robotics accelerator on campus. They had 10 startups in their accelerator to help them launch literally their new product into the marketplace. Our guest speaker and panelists this evening embody this commitment to robotics and drones. Let's give them another round of applause for supporting this sector. Okay, now to the fun part here. Before I go into the Evo Nexus stats, which I always like to do because they change every week, our companies continue to get better and better, raise capital, create their products. But there's no better way really to describe Evo Nexus than to show you some of the important products that have come out of Evo Nexus that really matter, that change business models, that in some cases make your life better. Let's roll it.
Is there any audio on this?
No audio on this.
As you saw, one of those products will make your pet's life better. It's called Clever Pet, one of our startups. Great company. Next slide. Okay, 56 companies we have in incubation now. 56 companies in incubation. Our portfolio of startups is larger than any venture capital fund ever to reside in San Diego. We manage more companies than any venture fund has ever managed in San Diego, and we do it pro bono. 115 companies have been in our portfolio, and we've had 11 acquisitions. 11 companies have been acquired out of Evo Nexus. 5 of them, even before they leave the nest, they're so attractive, they get acquired. So Evo Nexus is really producing the most important startups in San Diego. Next slide, funding. $675 million in funding, raised an outcome. We started with 3 companies in late 2009 in the Cricket building just down the street here. Doug Hutchinson, who ran Link Wireless, gave us the building for a year and said, try it out in my building. And that's where it started. We were there for a year, then we moved into Irvine Properties with 3 companies and 3 more companies, and look what's happening year over year, growing in revenue or funding generated by the companies and outcomes. Next slide. So people ask me all the time, why hasn't San Diego launched a Facebook, a Google, an Uber, an Airbnb? We're not good at that here. We don't have the infrastructure, the capital, the workforce to scale and launch an Uber or a Google or really Apple for that matter. What we do have is talent and knowledge in these sectors here. So this is the future of Southern California, not just San Diego. This is San Diego's and Southern California's future in innovation. And I can say that because Evo Nexus is ground zero. We see what's coming in at the ground level. So software as a service, security, mobile apps and web platform, hardware robotics, big data analytics, life sciences and healthcare, semiconductors, which is actually shrinking semis. But the growth area in the last 2 years has been in the blue, which is life science. So we've all talked about wireless health, connected health, digital health, and we talked about it 10 years ago, but it was too early. There wasn't even 4G back then, no LTE, no smartphone. So what are you going to look at your EKG on a flip phone? So it's all happening now. All the technologies are coming together, and it's going to really impact healthcare. So those are the growth sectors. So if you're in the audience and have a startup that's in this growth sector, come see us. Next slide. Okay, I'm almost done, but I'm saving the best for last. This is all about drones and robotics. It's all about past, present, and future. And as you're going to learn from the admiral and the captain and our speakers tonight, San Diego in particular has been at the epicenter of autonomous systems for many, many years. I mean, we have some people in the audience that weren't even born yet. But we've been the center of this. And we've had companies here, both companies in the Navy with research that's worked on autonomous systems or robotics long before it was fashionable, long before you saw Jeff Bezos launch a drone and carry a package. You know, it's here, it's solid. We have a base here we can build on. You always need a base to build a company or an industry on, and we've got it here with not only great DoD companies, but commercial companies and technology companies like Qualcomm. Roll the video.
That was a very fitting way to start off this event tonight. The future of robotics is bright. But first, I want to take a moment to recognize and greet all the veterans in the audience tonight. Why don't we have all the veterans stand up for a moment? And I believe we have some here from Reboot. Who's here from Reboot tonight? Woo-hoo! Continue to stand for a moment. I want to tell the rest of the audience who you all are. They're led, some of you may know, Reboot is an organization in town that takes the veterans who are getting out of the military and they prepare them for civilian life. So it's nice to have them out here tonight with us. So hopefully they can see what we're doing is very exciting and maybe want to join us. So remember who they are, and after the event tonight, take the time to talk with some of them and show them a little bit about how exciting our world is. Thank you. It's my privilege to introduce our guest speaker tonight, who you've been wondering who that is. He is really an icon in town, in the drone and robotics industry. A visionary and a terrific manufacturer. And he is Lyndon Blue. 25 years ago, Lyndon and his brother Neil came to town, and they had this vision of having a robotic drone, and they started the Predator. And about that, shortly after that, when I was over in, we're covering Bosnia, they had, this is before the actually was approved to be manufactured, they built a couple over and really used them during the war in Bosnia. turned out to be very useful over there. It gave us the vision that how terrific these could be and what we're doing today. So as a result of that, today over 740 of these robotics drones have been manufactured. And today they're providing surveillance. Back in the Washington time, they could only provide surveillance, but they're now providing surveillance and attack capabilities and protection of our armed forces. In fact, in any 1 second of the day, there's 60, a 24-hour day, there's 68 of those Predator drones over there providing us protection and attack capabilities. By the way, that's the way Linda looked back when we started the drone program. And this shows you how rich and prosperous he is today. So, we all also know Lyndon is not only a technologist, but he really is one of our leading leaders in our community today. So please help me welcome to our stage our keynote speaker, Lyndon Blue.
Well, I have to tell you that when Rory and Walt asked me to do this, I believe so strongly in what Nexus is doing that I could not say no. Truly, I don't normally like to do these things, but in this particular case, it's a wonderful cause, namely the technical advancement of San Diego. And that's what Nexus is all about, the advancement in young lives who get into the technical arena. They asked me to sort of commercialize what we do, and we do have commercial applications. We do border control and also fire protection, spotting wildfires. But the truth is that I'm a lot more interested in putting into the context of a social and philosophical role. I think that's where it's most important of all. This is a picture that shows Predator, actually a Reaper, which is Predator B. It's a running, firing Hellfire missile. Down at the bottom, for those of you who can see it, same payload as an F-16. These are not toys. The difference is that it can stay aloft 10 times longer than an F-16 or an F-18. Well, these are very significant developments in warfighting. And I'm going to show you an actual firing of a Hellfire missile. There's a missile away, there's a tank sitting out on the desert. That's what happens to the tank every time. And I say that not because I want to brag about the capability, but so that you will understand the precision with which they operate. And another, here's a Reaper dropping 400 or 500 pound bombs. Now there are 4 trucks sitting out in the desert. In the square, you hope to get somewhere close to that square. And that's GPS guided. First was laser guided. Point is, this is a much better way of warfighting than the world has ever known. And for the people who disparage, it is, you could say, the automation way to prevail when there are conflicts less expensively, with more precision, with less collateral damage. And that's the name of the game as far as we're concerned. And you could say, well, does it really matter? it really does matter. You're all familiar with this, but the important thing to take from this picture is what I call the leverage of terror. 9/11 cost the world economy at least $1 trillion. And maybe 2 or 3 trillion. But if you only assume one, and the cost was about $200,000 to pull it off, that's a negative leverage of 5 million to 1. Negative leverage to destroy of 5 million to 1. You've got to have pretty good technology to deal with that. In the end, why does it matter? Because we hate to see things like this. There's too much of it. We all want to avoid wars whenever we can, but when we are forced into one, it's important that we have the systems to prevail. Now, obviously, this is an American mother and her child, but this is a picture that really got me, because this was the posse, if you will. It came out of Mali when they kidnapped the 300 young girls. And these people were all ready to go. They had their own rifles, and they wanted to do something about it. And the point is that we, the United States, these are our friends. We need to be helpful to them in providing the technology of knowing where they took the girls immediately, so they can do the job of freeing the girls. And I have to say that predators were eventually used in that operation, but I think much later than should have been the case. Point is, these people want to live in the 21st century, not the 7th century. And it's with our technologies, our ideas, that can make that happen. We have to provide that technical leadership. Well, you've all heard about perfect storm, and I have to tell you that a lot of places in the world, there are situations tantamount to a perfect storm now. But the problem is it's not just one storm system or 2 storm systems. I'm going to give you 5 that I think. First of all, it's demographics. We're talking economics. An aging population, fewer people that are productive in work. Globalization. I happen to think globalization is a wonderful thing. But what we know for sure is that we're now competing to a greater extent than ever before in history with everybody else on the planet in terms of wages. We do not want to have the same wage scale as Bangladesh. Globalization makes it possible for people to compete in Bangladesh and a lot of other places. And what you have is an acute asymmetry where, typified by that picture of 9/11, where destruction has a leverage of 5 million to 1. We also have, I think, an increasing feeling of entitlements in this country particularly. And to me, it's because of a great deal of ignorance about the way our economic system works, the way it can work for the entire world. But unless you recognize the elements of this storm, you can come up with the wrong solutions for what you do about it. Now, one little bit of, I think it's very important to put this in the context of history. And this is a chart that is very meaningful to me. It's the blue chart is Western Europe, and that's the circuit for the United States, or the blue line, and the red is China. And it goes back 1,000 years. And the point is that the world per capita GDP was essentially flat for the 1,000 years before today. And it wasn't until about 1820 when there was this big inflection happened here. It took the Chinese 150 more years to get to their point of inflection. But the thing for, I think, all Americans to recognize is that we were as poor as everybody else up until about 1800. And Thomas Hobbes, a great philosopher, described life in 1651 this way. And I think you could say that the only good news there, life is solitary, poor, nasty, brutish. The good news is that it was short. You only had to live about 35 years under those miserable conditions. And you just have to say, well, what happened? And first of all, we know about the Industrial Revolution, where we learned to use energy. We learned that if we burned coal or wood or whatever else and boiled water, we could make steam and drive a turbine. That was a big deal. It also coincided with what I would call the liberal governmental trends that happened in that same time period. And of course, in 1776, there was a similar event that went on in this country. But it was because of that environment that energy and science and innovation could happen, and it was largely because of the freedoms that we have because of our free enterprise system. And that's when I go back to the issue of ignorance. If we don't understand this and don't appreciate it, we can come up with the wrong solutions in international issues. Again, what this set of circumstances did, it unleashed innovation and science, and it caused this tremendous compounding effect that caused this big inflection point. And the critical thing here is that's what happened in Western Europe and the United States. But it must happen throughout the entire world. And it's our science, it's our automation, our robotics, if you will, that makes it happen. I should have introduced, or I should have mentioned that I am an optimist. And I do believe that because of the technologies that a lot of you are interested in here, right, that there is an unlimited opportunity in the world. And this is critical, and we come to Qualcomm, and there's no place in the world more exciting in terms of ubiquitous information than Qualcomm. But when you have ubiquitous information that travels around the world at the speed of light, and you have unlimited energy, you do have the potential for unlimited wealth and improvements in standards of living. And that's a pretty worthwhile objective. But it takes the ideas of Western civilization to put it all together. There are a lot of places in the world that have the potential of all this development, who simply just don't have the tradition, the governmental infrastructure that makes a foundation in which this can prosper. And finally, the critical element of all this, of course, is the rule of law, which ultimately means that instead of fighting, war can become obsolete. And that's one of the objectives, as far as I'm concerned. That's the objective of the robotic systems that we have pioneered. So, final thought here. There are some serious storms out there, but for the surfers in the crowd, I'm one of them. You always want to be on top of the wave and you want to ride the wave. And it's so long as you're obeying the laws of physics and more recently some of the laws of automation, you can ride those waves. Well, that's sort of my introduction here. Now you're, I think, going to really hear from people who know how to put all this together.
Well, that is a fitting introduction to our further discussions and our panel discussion. However, then I got to confess, we were all hoping that you were going to give us a few secrets, your technological secrets, that we could all go out and make our drones. That didn't happen. So let me introduce the panel members. First, some people would say that, I heard it said that San Diego is ground zero for robotics. And one reason we can say that is because of Spaywar Systems Center. And so tonight I'd like to introduce one of our panelists, Kurt Walkenhouse. Come on over and take a seat. Kurt is the commanding officer of Spaywar Systems Center, professional engineer, by the way. And if you really want to understand robotics and the history of robotics, and go back probably as far as maybe beyond robotics, robotics goes back to the 15th century. Physics, Spaywar. So we look forward to your comments, and maybe you'll give us a few secrets.
Hopefully not.
And next I want to introduce Charles Bergen. Warren mentioned to you how Qualcomm is becoming a big leader in this area. So we're pleased to have Charles. He's the Vice President of Engineering at Qualcomm Robotics and runs Qualcomm's robotics efforts. Thank you. Last but not least, a lot of you know Tim McConnell. Tim McConnell studied robotics in college, MIT graduate. He actually wrote his thesis as he graduated from MIT on robots, I believe, and came out, been in robotics ever since. 3D Robotics was his. It was in Vision Robotics company, and he is going to be our moderator tonight. So say hello to Tim McConnell. John? Okay, all yours, Tim.
Thank you, Alan. Well, good evening. My name is Tim McConnell. I'm the head of engineering at Method Power Technologies, and we are a graduate of the Evo Nexus Incubator. And if you haven't taken a look on their website at the list of alumni of the incubator, you should look. It's pretty impressive. There's some great companies in there. In fact, Rory, I think perhaps we should, Evo Nexus should sponsor an alumni gathering or get together, and our fellow alumnus Tap Hunter should be in charge of the refreshments for that. So I'd like to thank you all for joining us this evening. We've got a great program tonight to talk about some really good insights on the history of robotics here in San Diego and the future of the things that we'll all be looking at. Like our panelists here, I've been engaged in robotics for a long time, unmanned systems, and I believe we have a strong intention amongst all of us to continue that growth here in San Diego and keep it going. I'm joined here on stage by three giants in our tech community. Each of them has a long history with local organizations that have contributed a tremendous amount to the growth of robotics in San Diego. To those who have been around high tech in San Diego, of course, Lyndon Blue doesn't need any introduction. He's been involved in aviation throughout his life, but locally his name is synonymous with General Atomics, where he serves as vice chairman. Lyndon presided over the development of the first large-scale unmanned aerial vehicle program ever. The Predator drones developed by GA flew over the Balkans in 1995, and the first overseas deployment of UAVs. Since then, drones developed by GA Aeronautical have led the forward momentum of UAS technologies. And Lyndon, I just wanted to say, I'm glad that our lives are no longer nasty and brutish, and from watching you bound up the stairs there, you're clearly also not short. Nice to have you here with us. Charles Bergen is Vice President of Engineering here at Qualcomm, and he leads the development of robotics for Qualcomm Research. Under Charles' watch, QRC has built an impressive array of technologies for vision, sensing, computing for robotic systems. He's also an ambassador for the Snapdragon family of processors and helping to make these technologies available to developers and to the commercial world. I consider Charles to be the model of what we're looking for here. He was educated here at UCSD with a bachelor and master's degree, and then we kept him here in San Diego, and he's helped to grow the community, so that's really what we're looking for. So, Charles, nice to have you here. Captain Kurt Rothenhaus serves as Commanding Officer of Space and Naval Warfare Systems Center of Pacific, which is SPAWAR to us San Diegans. SPAWAR has been developing robots on Point Loma for over half a century. They've really addressed some of the industry's most difficult challenges of command and control and keeping things running in the harshest environments. So a lot of really impressive work there. And Captain Rothenhaus, it's an honor to be sitting here with you on Veterans Day, and I just want to thank all of our veterans for all your service. It's really an honor, so thank you all. It's a pleasure to be here. So I prepared a few questions to catalyze the conversation, but please don't feel constrained by the questions I ask. We're all here to hear the great things that you all have to say, and we'll have some questions from the audience at the end. But for now, let's start with a few that I thought up, and then we can see how we flow from there. So Captain Rothenhaus, Kurt, SPAWAR has been developing robots since the 1960s. Past and current projects include small UAVs used in the theater, including Raven, Puma, Wasp, magnetic hull climbing robots, throwable robots for marine interdiction, robots to find and explore tunnels, undersea robots. What are the unsolved problems closest in the minds of you and your teams to better equip robots to augment our troops?
Sure. Well, it's a fascinating question. And first off, I'd like to echo your thoughts for Veterans Day. I want to say thank you to all our veterans out there, and of course, thanks to the industry partners here who give us the tools for our folks so they can fight and win. So I appreciate the opportunity to be here tonight. One of the things from the perspective is we have been working on unmanned systems for many years, and what we're seeing is as the numbers of these systems grow, we need to examine how do we better command and control them. How do we not have the numbers of people associated with managing those systems continue to grow. Right now, I think it's safe to say that for every unmanned systems, there might be a team of people working on them. In the future, we need to have one individual managing multiple systems, and so that's one of the challenges we're looking at. Also, we're examining ways, how do we get data off those platforms? How do we basically take the ISR data that's on board the unmanned system and get it back to where it can be processed and analyzed? Bandwidth is a challenge. Processing power on the individual devices is a challenge. So those are things we're looking at. And then we're also looking at, how do we better power these systems overall? There's big challenges in if we want systems to run persistently, unmanned, and how do we keep them gassed up, so to speak? So those are some of the big challenges we're looking at as specific. And we've made some great strides. We're very proud of the work that's been done. And I have the honor of serving there and representing the 4,500 civilian scientists, engineers, real patriots who are working on those systems. And they're also, of course, joined by many industry partners.
That's terrific. Congratulations on that. Continued work.
I think that mirrors the kind of problems you see on the commercial side, though, because you've got basically the same thing going on. You've got one guy every 100 meters trying to drive a drone that's taking pictures of a farm or refinery or whatever you're trying to inspect. It's just not going to work. It doesn't work from a manpower point of view. It doesn't work from a scaling point of view. So you actually need the same autonomy, the same kind of capability to avoid obstacles, fly to a waypoint unattended. Maybe you have a call center that you can get back to if you run into trouble where the autonomy can't function. And then how are you going to do that over long range with current radios, which are pretty much limited to a kilometer? You have to use something like LTE. And so, at least for Qualcomm, we have that sort of unique combination of computing power, so we can do some onboard autonomy, ability to view, call out to a call center, literally actually with an LTE radio, and putting it all together into one vehicle that then can solve all these really interesting problems is an exciting part of what Qualcomm's able to bring to the party.
Well, it's interesting to hear the similarities between the types of challenges you're facing. I'll be interested to hear, all three of you talk about how you can collaborate together, how the things that are happening in the military research side and the commercial side can be brought together to push the forefront forward. Linda, General Atomics put the first military unmanned aerial systems to work 20 years ago. In the time since then, GA has been a leader in UAS development. Avenger, Gray Eagle, Reaver, Altus for high altitude civilian work. Turbofan propulsion, stealth technologies. In that same time, the lines have blurred between military, commercial, and consumer drone capabilities. The effort to launch a UAS has gone from millions of dollars in the backing of the GA or the government to a few $100s on the internet to even less money to build one yourself. How is GA taking advantage of these huge developments and changes in the industry to continue its leadership?
We're focused on the cost, for sure. And that's really why we got into it in the first place. We had, after college, my brother and I started a banana plantation in Nicaragua, and the Soviet helicopters were killing all our friends. And we took exception to that and figured we'd like to tilt things in their favor. And if the Sandinistas didn't have oil fuel, they couldn't fly their helicopters. And so the idea was take a hydrocopter, small airplane, load it with high explosive, fly it into the oil storage tanks in Managua, and no fuel for the helicopters, no killing our friends. Well, the good news is that there was a change of government, the Contras prevailed in the elections, and it's a good thing. Probably I'd still be in jail if it hadn't turned out that way. But the point was that it was a matter of using technology, and at that point, GPS was sort of unheard of, but we'd heard of it. And it seemed to be an opportunity to use that technology and drive down the costs and make it possible to have greater security at lower cost. So, a combination of technology and an objective of reducing costs.
So how much did the GPS receiver cost?
A lot. And of course, that's well, I can only imagine probably $20,000.
How much did it cost on a cell phone?
Yeah, right.
10 cents. 10 cents.
Sure, there you go.
10 cents is the other.
Yeah.
Wow.
Now, that's just, it's my guess, but what an incredible accomplishment. And, we all owe that to Moore's Law.
Absolutely.
And for that matter, most of the good things that are going on in the world today. And that's why I wanted to put it in the philosophical context. With that capability, you can do anything. And on that, some people, I have fun asking, how many cell phones do you think there are out in the world? And because Paul Jacobs has told me, I don't know what the answer is. But people usually grossly underestimate that. I mean, you got to think that there are 7 billion people in the world. A lot of them are in Africa and India and China and the boondocks otherwise. Can't be very many. Maybe, what, 6 billion?
6 billion.
Well, it's interesting, the sort of ramp that you allude to, Charles, of the huge cost of things and bringing them down, and Moore's Law helps with that, but also in companies like Qualcomm that have the vision to be able to take these technologies and say, how can I apply those? These things that people used, only 10 years ago started putting in cell phones, and now we're realizing, wow, these are all the same things that we can put into robotics. Qualcomm has really been pushing the envelope on robotic development, a lot of great investments in the arena. Snapdragon processors with, object identification, motion tracking, SLAM, 3D modeling, optical flow, Snapdragon flight processors for drones, the investment in 3D robotics, the purchase of K-Mill Robotics, the investment here in the robotics accelerator. What are the challenges to finding the right targets going forward, and what will be the focus for Qualcomm in new investments in robotics area?
Yeah, I think actually listening to the list that way, it sounds more impressive than when you live it. Because when you're living it, it's almost, each one is its own little struggle. I think for us, there's that initial challenge of, we're selling to such a great platform in the mobile space that we have to find something of similar volume. And so drones was an easy target because it was the only thing that really had the right volume. And when you have only one thing that has the right volume, then you know what to do. And so when you ask, well, what do you do next? There's some challenges there. I think part of it is to take the platform we have in drones and expand out into non-consumer spaces. So you start off with prosumer. People like to say you make toys for a living. Okay, but prosumer, so the action camera, flying action camera. So we're starting today, and we have a lot of traction there. But then quickly move into the gathering of actionable information. So you're looking at refineries that right now have to put a guy in a climbing gear, and he hangs out over the side and tries to measure methane and hopes that if there is methane, it doesn't spark and cause an explosion. So now we can send an aircraft there. Big sea, North Sea oil rigs, bad weather, you still have to go out and do an inspection. Well, not if you have an aircraft that you can throw away. Today you can do it, you can fly an airplane out there and take a look, but it's a multi-million-dollar aircraft, and certainly if the weather's bad, you want to send it back. Already, Scan Eagles actually coming from the military used for the Alaska pipeline inspection. And again, it's an area where, sure, during the summer months, it's great, minus mosquitoes, but during the winter, nobody wants to be there. It's lethal. If you go off the road, you can die really easily. But an aircraft that can fly along, do inspections, look for leaks, actually use multispectral imagers that can do a better job at looking for leaks than a human can. It's really exciting. And I think many of these use cases, already people are coming to us. They're saying, I want to do power line inspection without the helicopter. I want to fight fires or a thermal imager without flying a helicopter. I want to examine my crops. I want to, the list goes on and on and on. And I think for each of those, there are often special use cases, special things we can do. And aggregating all of those use cases together, we start to approach the kinds of volumes that you see in sort of lower-end consumer phones. And that gets exciting again. And as the information starts allowing people to be more efficient, be more productive, then it's okay if the aircraft costs more, and if we can somehow arrange it so that we get a bigger share of more expensive aircraft, then it gets even more attractive.
Very exciting. A lot of great areas to be approaching. I remember asking you a question a couple of years ago when you were speaking here about what drove you for which things you went at. You said, well, my boss tells me to sell chips. So.
Yeah, we still, in the end, they count the chips, and, oh, sorry, Charles, not so good. And eventually we'll get into other things. And people say, what about vacuum cleaners? What about service robots. The volumes there are actually lower right now. But I think it'll be similar to automotive. I think if you can afford a car, you'll probably have some number of service robots in your house.
Great. So my next question is for all three of you, and you can all just sort of jump in and think about this with me. So a report from the Brookings Institution states that America's advanced industries encompass the country's best shot at supporting innovative, inclusive, and sustainable growth. It also states that San Diego is the third most patent-intense region in the world. UCSD has formed the new Contextual Robotics Institute and is a world leader in engineering education. Tijuana is putting out great young engineers and really building up a lot of capabilities on the other side of the border. I just had a conversation out here in the lobby before I came in with Jeff of Next Robotics, who said that people in Austin were trying to lure him away from San Diego and get him to set up shop there. And so I want to ask all of you, we've got such great mind share, so much genius and talent here. What do we do to continue the growth, to inspire people to be here, and to keep the brain power here to grow San Diego's robotics community?
Well, one of the things that I think we all should be excited about is the border region. San Diego is pretty unique. There's a tremendously vital technical establishment in Southern California. But right next door, we have Tijuana and Mexicali, and there's an almost unlimited supply of very, very effective labor that can be acquired at less cost. Well, the combination is a very dynamic one that is causing a lot of manufacturing to reverse course. And 15 years ago, it was all going to China. Now it's coming back. And it's a recognition of how creative and productive you can be with the kind of automated science that we're talking about. And that Qualcomm has done so much to advance.
From the U.S. Navy perspective, in 2014, IEEE did a ranking of the robustness of patent portfolios. The U.S. Navy was ranked the #1 government organization for its patent portfolio. We're very proud of that. A lot of it is in conjunction with industry. It shows the Navy's how it values intellectual property, and not only just gaining intellectual property, but then sharing it. We have a aggressive transition arrangements where we can share that intellectual property with industry, that can commercialize it as it makes sense from a security perspective, and give back some of those insights. The military tends to have a pretty far time horizon for its research, so some of those patents that have been on the shelf start to become more commercially feasible later on. And so that's a lot of it speaks to San Diego as a region being one of those innovation hubs. From a strategic perspective, this is the home, the largest Western Pacific, the largest Pacific naval installation. And we also have the benefit of being in a region that is a high-tech hub, and we're able to retain and attract great people and work with great people to work on these types of problems. But overall, I think, as a nation, our strategy, our security rests on a technological advantage and an ability to basically have a superior set of kit when going up against any potential adversary. So we rely on San Diego as a region to help provide us with those necessary equipment.
Right, thanks. And can you describe a little bit more about how your plans to reach out to local industry and how you kind of share that technology and work with companies here?
Well, we have a tech transition office, folks who are dedicated to looking through our patent portfolio and working with industries that are interested to see, hey, here's something that makes sense. We'll go ahead and commercialize it. It's been very successful. There's some companies out there, startups that really came from some of the innovations that were done for the U.S. Navy. We also, of course, do broad area announcements, contracts, and other vehicles to bring in industry's talent. It really is a compelling mix to have the best minds from the industry mixed with the government and our civilian scientists and engineers and really come up with those unique solutions to some of the problems that really industry isn't quite focused on yet. Some things out there that may only make sense in a military context, but throughout history, you look, an advancement made 10, 15 years ago along the lines of the military, make their way into the commercial world and make everyone's lives a little better.
I think the big deal is to have more companies here in San Diego, frankly. I think you've got Silicon Valley, you can't throw a rock without hitting a startup. And we don't have that here. Basically, to some degree, Qualcomm's drained the lake. We had a lot of different small companies, and then Qualcomm came super successful, and a lot of those engineers moved into Qualcomm. It made it hard for other companies to survive in that environment. And I don't think we ever really got back to a steady state, a good steady state anyways. And so when people say, well, Intel is here, now Google is here, now all they come with this list of competitors in the job space, is that a problem for Qualcomm? Actually, I think it's a good thing. I think it's good because we've had problems in the past where people say, well, I worry about coming to Qualcomm in San Diego because there's not too many other choices, but for some reason it's not a good fit. What am I going to do? I'm going to Silicon Valley, I'll just move there first thing. And I think that as the big challenge is, like you said, we got UCSD, and they've got 8,000 engineering students, and then we've got the big companies, Qualcomm, maybe anchoring that. But in the middle, if you're just out of school, now is the time to do a startup. That's what I did. As a lot of people do. They go to these little tiny 10-person companies and try to make it big, try to make a difference. And how are you going to do that if there's no company? You're going to go someplace else. And so creating small companies, that's what the accelerator is for, is what Nexus is doing in incubators. Finding a way to make that attractive, and it doesn't look like this big valley where there's nothing there. And your only choice is Qualcomm or leave. That's going to be the key.
I would also like to add, so this year, almost $1 billion was contracted out from San Diego. Of course, close to a quarter to small business. And so I think I agree with you that there's a lot of opportunities to increase the numbers of small businesses here in San Diego. And I think there's a terrific synergy that comes from having small businesses participate in the development of the new system.
And the slope is good. You can see the stats, everything. Actually, we're definitely doing a lot better, but we just have to keep pushing. It's going to get harder.
Sure. And clearly, one of the issues there is, providing capital to these companies. The European Commission funds over 100 collaborative projects on advanced research into robots. What can we do to encourage government agencies and encourage private funding to be able to support the growth of all companies so that people aren't trying to bootstrap from their own walls?
Well, I think I can pitch the accelerator. I think that's a good example where we put in money, Techstars puts in some money and some expertise, and then make it easier. They get mentoring, they get a lot of support, they get free office space. So there's easy things to do. I think the harder thing generally is to get out of the software space. I'm a software guy, so I like software a lot. But from my point of view, too many software companies, because people think software is easy and hardware is hard, and not enough hardware companies. So we need more companies actually trying to do difficult work in hardware.
And on the hardware side, Lyndon, you made a point about the ability we have to do things across the border. When I was running engineering at 3D Robotics, I was thrilled at the ability that we had with engineering, Mesa and manufacturing Tijuana and engineers down there as well, to be able to get a call from the factory and hear them say, we've got an issue here, we need some engineering discussion about that. And I would just throw some engineers in my van and drive down, and 20 minutes later we'd be at the factory and we'd be talking it through and we'd have the problem solved by the end of the day. It was just a great experience. How can we capitalize on those type of that close cross-border collaboration to get people more encouraged to develop hardware locally here?
Just one thing, the border's been a barrier throughout history, and the barrier's coming down increasingly with the cross-border capabilities. And just in Tijuana, the new terminal is being opened so we can park the car on this side of the border, one across, and fly them to you. So, the time that you spent, I'm sure you spent some, time in queues trying to get back across the border. And, all those things count. You can't have friction in the, in anything that you're trying to make work. The amount of friction needs to be kept at an absolute minimum. And so it's avoiding those kinds of problems with the border. And also the whole fluidity of money. Nothing happens really until there's money to pay people and to launch a new idea. And that's one of the things that's so great about EvoNexus.
I think one of the big shifts to talk about with manufacturing is people, right now manufacturing is basically set up for just-in-time delivery. So you can think of like a Walmart, and they get a ship coming in from Long Beach and the stuff gets unpacked and sent to a warehouse someplace else. But it's all timed so that the toilet paper hits the aisle right when there's not enough toilet paper. They don't have to store a lot of stuff, at the store. But now it's going to be completely different. Now it's going to be everything's manufactured just in time. So you order your Tesla, it's going to actually get built right then, starting then, and delivered locally, which means the factory needs to be nearby. It needs to be out of the Nevada desert with big solar panels on it. It can't be in China. If it's in China, you've got a problem because you're competing against, let's say, Tesla could be there, BMW's built in Germany. And it's 6 weeks to get your custom BMW from Germany, but 6 days to get it from the Tesla factory in Nevada. Tesla's going to win because there's going to be guys who say, "Well, I want my car now. I'll just get a Tesla, rather than a BMW." And Tesla wins. And I think there'll be a lot of wins that way, and a lot of opportunities actually to add the latest features, the latest gadgets, new technology into the car because the car's not already built sitting on some warehouse floor someplace.
Research. We've seen some tremendous advancements in additive manufacturing to close the gap in the time between inspiration, development, and putting something into service, or at least prototype. And so that's very exciting. And there's some real, fantastic micro manufacturing going on right here in San Diego that we leverage every day. And we'll have folks working on a prototype. They'll work through it and they'll interact right away with those folks out in town, get the part, and then start moving forward with prototyping. So I think that's one of the other strengths here in San Diego is that growing micro manufacturing capability.
It breaks some of the models people have in their head. They think cars are built on assembly lines. Maybe not. Maybe in the future, since the car is custom, I don't know if I'm making a two-seater, convertible, or big SUV. I actually need a big robot that can just grab the whole car frame and swing it around like it's a toy, and then put the parts on that I need, rather than have this very complicated reconfigurable assembly line, car by car. So, but then the robot that you need, of course, is a lot more complicated. It has to be able to do a lot more different kinds of things, different arms and attachments, be able to sense the vehicle that it's working on, or visually recognize it. Lots of cool problems to solve from an engineering point of view.
Yeah, it's fantastic. It's amazing. And I think, if you can imagine in a military context, if you have an adversary who has a similar capability, that ability to rapidly prototype and deliver something, get it out to the field, will grow as the technology gap continues to decrease between other potential adversaries in the U.S. That ability to innovate quickly, find a new way or mechanism to do something and get it rapidly enhanced, that additive manufacturing and micro manufacturing will be a big part of that.
In a word, it's all about information. And one way or another, it's information that makes things happen. And the thing that I try to get into when I started, that's traditionally been one of our greatest advantages. Still is, but information is traveling around the world at the speed of light. And that makes the Middle East a second and a half away. And so we have to recognize that. We have to use information better than anybody else if we want to be competitive.
Sure. You were talking about, Charles, some of the technological innovations and staying on top of those. We've got the new Robotics Institute at UCSD. I was reading today at the CSAIL lab at MIT has developed this new soft gripping hand that can identify things tactily. It can pick up eggs and CDs and a piece of paper and do really
CDs, what are those?
NASA's got some new extensible camera technology here at the incubator. Telzal's developing some great new sensing technology for obstacle avoidance and aircraft avoidance. How do you all stay connected with these rapidly changing technologies and to leverage the quick changes in the industry to be able to turn those around into advancements for your companies and for the industry?
Read a lot. Spend a lot of time on the internet. And again, the incredible thing about that is that literally any bit of information in the world is pretty much available at your keyboard. There's never been a phenomenon like that in the history of the world. And it's very powerful. It is and will continue to do a great deal of good. There are also some downsides.
Yeah, so two things come to mind. One is I have a huge advantage in Qualcomm because I've got all of the mobile device manufacturers that are coming to us, so I get a preview because they say, well, I'm building one of these, and I want to use your chip for that. So I learn a lot about what's going on just from that interaction. And the other one actually is talking to university professors. So we have a pretty strong university relations program inside of the research division, and I liaison to UCSD, and one of the great things about that program in general is that we send guys out to those universities and they do recruiting and other things that we need for hiring new guys and women. But the key thing for me is that they sort of become an intelligence arm for the corporation. They go out and talk to professors, find out what's interesting, what's going on, maybe nudge their research towards a direction that's favorable to us, or maybe away from something we've tried and didn't work. But by doing that and reading a lot on the internet, I think we can do a pretty good job of covering both sort of the undercovered. So university research typically is done in very dry papers that don't do well up on a webpage. But if you combine that with the sort of the flashy videos and other things that you can use, you can actually get a pretty good view of what's going on.
We have a number of mechanisms to really reach out and learn what's going on throughout the world. We have folks who live in other countries, participate in academic institutions there. We have a very strong relationship with obviously UCSD, SDSU, all the universities here in Southern California. We provide resources for their research, and that allows us some access to understand what they're doing and collaborate. And also industry. We learn a lot from small business, from industry. There's some just amazing research going on. And one of the challenges we have is we're trying to operate these unmanned systems in a very unstructured environment. There's no road signs, there's no lanes on the highway. So some of the algorithms and protocols and mechanisms that may work in a more structured environment don't necessarily work in a more chaotic, less formatted domain. And so we've reached out to a lot of the great institutions out there throughout the country to really figure out that hard problem. And there was recently a New York Times did an article on robotics, and we get an opportunity to Google it. It's a really interesting look at some of the challenges in unmanned systems, and really kind of focused on that notion of how do you operate in an unstructured environment? How do you have true autonomy in those environments? Not just moving, but making decisions. And then from a military context, how do you have, if you have an adversary who's building autonomous systems as well, how do you interact with their autonomous system? Which is a tremendous, almost an arms race you can predict in autonomous algorithms and systems.
Thanks.
All that said, though, I have to say I get surprised almost every day by something. Usually I get it just starts with an email. Did you see the drones that can build a road pattern? No, I didn't see that. I didn't see it. But you can see it happening to them too, because sometimes I get the, oh, did you see the drone that can also be a boat? Oh, years ago, was, one guy made one of those, right? And you read the article, it's a brand new idea. So I think what's really happening is that, there's an old saying about, as the radius of knowledge increases, the area, right, is going up by the square. And that's really what's happening. As all these little radiuses of knowledge of your area, the sum of the knowledge, the total area of knowledge is really going up, it is going up by the square. And the result is there's no way to know everything. It just, it's been, impossible for a long time. But now with the acceleration of the technology of people being able to take a DSP and do, in a few equations what used to take, a whole bucket of discrete logic, you're able to do things that, as an individual that were only possible by a whole team of people. And when that's possible, when every individual student, can be an army on its own, I mean, it causes you a lot of trouble. But for me, it's super exciting because, an individual can come up with this great collision avoidance algorithm. They can do auto landing. They can, figure out ways to navigate with, in very dark situations or in closed caverns or first responder situations where buildings caved in and it's completely unstructured. There's a lot of really interesting work, and there is, a lot of stuff that goes unnoticed. So I think it's mostly actually using, each other and saying, hey, did you see? And most of the time it's actually, no, I haven't seen it.
It's a great point. We are just beginning. So that's a great point. It is ultimately for us, it's about safety. It's about not putting our folks in harm's way. And we look forward to the opportunity to benefit from that innovation.
Well, I'm having so much fun hearing how you all come from different perspectives and sharing ideas and work together. There's tons more things I'd love to ask you, but we're always pointing out that we do need to open up the floor to some questions from the audience. So.
We should have mics coming.
So I'm curious about how much time in your respective research and development institutions do you spend on worrying about behaviors of individual units, robots, flying robots, whatever, and how much you spend on the idea of swarms and intelligence in the swarm of a number of units.
So there's some fascinating research going on in swarm autonomous systems. The notion of following some of the, basically learning from Mother Nature how the swarms of animals and insects operate and try to map that behavior to how we control and use autonomous systems. It is absolutely fantastic. The Naval Folks Graduate School just recently did some great research where they flew a number of low-cost unmanned systems, and we're learning a great deal. So we do spend a lot of time. One of the goals is to drive down the cost of these devices, make them more affordable, have more of them. I think that's probably a big part of the success is having more of them.
So if the birds can swarm, so can we.
We women in the front have a lot of questions. I'm Becky Vincent. Our company is Vincent Enterprises. We're a local consulting company providing engineering business solutions in electronics, aerospace, and defense. And my question is really for the captain and Mr. Blue regarding the ABU class. I've read in recent months that in the 2016 budget, it appears that there will be significant funding, at least the last that I read, for that program. And I'm wondering what your crystal balls say about the future of the ABU class.
The future of what, Becky?
The U class.
Oh.
So I'm not too familiar about the funding line. It's a nav air system. We're a partner on it, and SBA was working on some of the components in it. I wouldn't want to comment specifically on another program. But I will say that, watching and interacting with the program, it is truly exciting. The capability and the potential to bring as an ISR platform for carrier radiation. And some of the same challenges we brought up early on exist for that type of platform. How do you get data off of it? How do you process data on the platform itself? And how do you operate it in a manner that is consistent with what we have on ships and other Navy units, which are minimum managed. We don't have lots of people to be able to operate them. So I know those are challenges they're working through, but I'm not familiar exactly with the budget or what's going on in 2016. My apologies.
Okay, I'm a little bit familiar with it, Becky, because as you may know, we're competing for it. There are 4 of us, Lockheed, Northrop, Boeing, ourselves. And it's a great challenge. The Navy, I have to say, is late to the UAV party. And it's very important that they get on with it. The problem has been that and I probably shouldn't be answering this question at all, but I'm going to do it. There's a great conflict in the physics between airplanes that have long endurance, which is key to predators, and they can fly 40 hours without refueling. That's a big deal. Long endurance, low observable stealth, or strike capable. And unfortunately, there isn't a set of physics that gives them all those answers in one airplane. So the Navy, I think, is having a great deal of conflict about which it is that they go for. Long endurance or strike. Well, I'm sure they'll come up with a good decision if they have a chat. And it's because it's a very difficult decision. When you have to land on a carrier, that's a very interesting exercise. And part of the rest of the problem, there are only 11 carriers that can take the kind of UAVs we're talking about. Well, now, I don't think there's a really good solution. I think there's a better way to do it, but we'll see.
So with the applications that have been listed, it looks like it's going to be a bright future, and hopefully things will be great. I wanted to get your views on 2 of the negative things that might happen. One is with the power that is available to every single person. Like, for example, the automatic gun fitted to a quadcopter could be very damaging, right? If it can detect the face of people. Does the military think about such scenarios? And are there easy ways to handle such things? And the second question is, with the advancement of robotics and automation, how are the jobs going to be replaced? And I would love to hear your thoughts on both of these. Thank you.
I can do the jobs one. I think so. There's a bunch of statistics about that. I think it's something like 60% of the jobs are destroyed every 4 or 5 years, and for the most part, we don't see it happening. But if you think back, it's pretty easy to find them. Telephone operators, gone. Elevator operators, gone. There's a whole list. Actually, it's already tellers, bank tellers, mostly gone. I don't like to go to a bank teller. I just like to talk to the machine. Fast food, actually, the server at the front, mostly gone. Actually, now there's kiosks, now there's phone apps, so you can go to the McDonald's app. Not here yet, but the McDonald's app, you order your food, and if the phone watches how far you are, the point of sale system in the restaurant knows how long it's going to take to make the order, and right on time you get super hot fries and super cold shake. So, I think there's going to be more of that and more of that, but there's a large number of jobs that are going to be created. So, actually Lyndon knows the number like the rest of all of us, so I think the number is something like for every Predator that's flying 24 hours, there's 168 people who actually are supporting the aircraft. And it's only like 8 pilots. It's mostly because there's so much information coming off the platform. It's people looking at, oh, here are all these images, here's all this radar, here's all this stuff that we're getting electronic intelligence off the aircraft. And that's going to be the same for other aircraft too. The delivery drone that's trying to deliver a package to your door is also taking footage of the landscaping at the golf course and saying, hey, by the way, for $1, I'll tell you where you need to water today. But somebody needs to write the software, somebody needs to analyze the thing, somebody needs to go to the guy and say, for $1, I'll tell you where to put the water down. All of those jobs don't exist today. Right now, they just run the sprinklers on some standard schedule or have a guy with a clipboard. You can do a lot better with an aircraft, even if the aircraft wasn't designed for that purpose, and it's like a flyover job.
Sure.
Our observation is similar that, obviously, as new technologies emerge, there's some roles that are no longer required. What we have seen historically, though, is there hasn't been a machine yet that can necessarily replace the creativity, the inspiration, all those things that come from people. I think it was The Second Machine Age, a great book there, where they highlighted the fact that the best chess player or the best chess software system couldn't beat a good chess player with a good piece of software to help augment their capabilities. So I think there's still terrific opportunities for a number of folks who are in these fields and develop and be part of a successful and functioning future.
Schumpeter called it creative destruction. The point being that every time there's this kind of a technical revolution, yes, it puts people out of telephone operators out, do something else. The sewing machine multiplied human productivity by a factor of 20. The number of stitches that can be taken. Well, so what creative destruction really means is it's another word for progress. And in progress, human beings are made more productive. And they're freed of the tedium. When I was growing up, saw some guys digging ditches. And that looked like really hard work, but very hard. I didn't want to do that. And I asked my mother how I avoid that. She said, work hard in school. So the point is, with information, you take advantage of that. You are a part of that creative destruction. And humankind benefits because everybody is more productive.
Great. I know I'm supposed to ask the questions and not answer them, but I will throw in the point that when I've been involved in robotics, that you're always looking at the 3Ds for the jobs that you're trying to get done, dull, dirty, and dangerous. And a lot of the jobs that you're trying to get robots to do are, as you said, things that are really hard work, or things that are not really great places for humans to be. Anyway. So let's enable humans to do things that aren't such awful jobs.
Okay. Ready, we're done.
Okay.
With everybody, so we're going to have the panel stand up here and want everybody in the background in the picture. So Joe, come on up here. We did this at demo day, it was a lot of fun. So YouTube will be on our website, on our homepage. So Joe, you need to stand up on the chair here. Look on the chair. Don't fall through the screen. Go get up there, I'll hold you. Get up there, got it? You okay? All right, it's on the $10,000 screen.